Hello and happy Septandy! That celebration of all of Tandy's marvelous machines, including the Coco, without which this channel would probably be called Videotex Town. And welcome to Game Revolutions, the series where I code a Moon Patrol clone in assembly language, and take about 10 times as long as the folks back in the day did, and they didn't even have all the modern development tools I have. I guess maybe I should just blame my development tools on my slowness and not my own ineptitude. Last time, I used a modern tool to design the big boss. By the time I was done, I ended up with a bunch of bytes. Today we import those bytes into the assembly language and get them to display on the screen. But even more importantly, we get those layers of the shield rotating that our player has to poke holes through using the bullets. Now that we have our precious boss data that tells us how to draw the boss, it's time to draw the boss. So I went to my progress table, and rather than popping up new feeblaws and rocks and holes, all I'm doing is I'm waiting 10 ticks and popping up the boss. I contemplated doing stack blasting, but this just doesn't happen often enough to make it worth it. So I just made a nested loop. The outer loop goes by rows, and the inner loop goes by each column within the row. And I just read and store 2 bytes at a time, where X is pointing inside that boss data, and Y is pointing into the off-screen buffer. I have a couple constants that Y gets offset by, which determine where the boss is going to live. I will say straight off at the beginning, even if there are no bugs, this is not going to work. Because start boss is only called once, so it's only going to draw the boss into the off-screen buffer that was off-screen at the time. And so we're going to see it flash. Whenever the off-screen buffer that has the boss goes on screen, we'll see it. But then when the other off-screen buffer goes on screen, we won't. So I'm just expecting to see it show up hopefully in the right place, probably flashing. That's okay. Well, I was right that it would flash, and it did take, I guess, about 10 ticks before that happened. But that doesn't look like the boss. Okay, I think I found the problem. Our destination register Y, we have to move it up a row every time we finish a row. We're actually drawing it from the bottom up. And this was my masterful way of moving it up by a row. This moves it up by 32 bytes up to the next row, but not the width that it had already drawn on the previous row. I really meant to do that. This will subtract the 32 bytes to move it up and subtract all of the bytes forward it moved to the right for the previous row. This will definitely work. There we go. There we go. That looks like it's all there. Okay, so to take care of the flashing, I went into my buffer info structs. We have 2 of these, because we have 2 off-screen buffers. These are the structures that just kind of remember where things were drawn on that particular buffer so we know how to erase it. I want to add a bit to it, so I just added a flags field, and I filled out the first bit with this. It's an indicator that tells us whether we need to draw the boss into this buffer. So this starts off just being 0, because it's not boss time yet. But as soon as it's boss time, the start boss routine gets called, and it ORs in a 1 for buffer info 1, and ORs in that 1 for buffer info 2. It also sets some global state to ensure that we do some boss-related things within the main loop. When the main loop calls the draw boss routine, it'll now have 2 cases. Case 1 is that the off-screen buffer needs to draw the boss, in which case it does all of this code that we just saw. And then it zeroes out that flag. The boss isn't gone, but we don't need to draw the boss. The other case is that the boss is active, but we don't need to do that initial drawing of the boss. In which case, we're going to end up right here and do nothing. This is where I need to start adding code to do rotation, but one thing at a time. Hey, hey, hey! Why don't we try shooting the boss? Yes, this is what happens when you don't have any code to handle it. In fact, the funny thing is, that's a little similar to what will actually happen when we need to shoot the boss. We'll be making holes in it, just not these flashing line holes. Okay, it's time to animate the shield. I have some code I'd like to try out. Each layer of the shield will get its own copy of this struct. This is a constant number that tells it how many ticks of the game to wait before scrolling at 1 pixel. And then this is the counter that actually counts down from that max to 0. So this stays constant, and we just reset the current with the max every time it goes down to 0, and animate the rotating of that layer of the shield. And here's the data for those structs. We've got 8 layers in the shield, so we have 8 copies of this. While I'm still testing, I just have each layer rotate at the same exact speed. So they each wait 10 game ticks, rotate to the left 1 pixel, wait another 10 game ticks, rotate to the left 1 pixel, and so on. So they'll all rotate in tandem. And back to the draw boss routine. Here's the code that checks whether we're doing the initial draw of the boss, and if so, we do it. And I used to just return at this point, so all this code down here is new, and this code will do the rotation. The idea is, rather than redrawing the entire boss every time, we only draw the parts that changed. So for example, let's say we're currently drawing into off-screen buffer number 1. If so, then that means we're going to copy from off-screen buffer number 2. Y is my source, and U is my destination. Y is pointing to the boss in the source offline buffer, and U is pointing to the boss in the destination offline buffer. And that leaves X free to scan through all those infos. So X is going to scan through this layer by layer. And so now it's time to start our loop. We'll have 1 iteration of this loop for each row of the shield, and we decrement that wait counter so that we're going to go at the proper speed for each layer. And if we're not 0 yet, all we're going to do is just copy the shield as it was, no rotation. Otherwise, we do a rotation. The shield is 6 bytes wide, so we're going to do 6 byte shifts. Most of the shifts just look like this. We grab the source byte in the source offline buffer. We rotate it to the left. That means whatever was in carry will end up in the right side. And then we store that in the destination offline buffer. We move on to the next byte to the left, rotate it to the left. So whatever rotated out with the previous byte gets rotated in to the new byte. And we just do that all the way down the line. We do treat the rightmost byte a bit differently. We load it from the source, we shift it to the left, but we don't write it out yet, so we just keep it in B, waiting until the very end. The reason is at the very end, we'll have rotated the leftmost byte, and we want to know what's in that carry bit, so that we know whether we need to OR that bit into the least significant bit of B. So we either do or don't need to, and in either case, we finally store it. Now you might think we're done, but recall that each pixel is 2 bits worth. So all we've done is we've rotated 6 bytes 1 bit. We now need to rotate those same 6 bytes 1 more bit. But it's a bit easier this time because we already have those bytes in the destination buffer. So we can do the next rotate in place. We're no longer copying from one offline buffer to another. We already did that. So now that they're in the offline buffer we care about, I can just rotate them all in place. But we still do that same trick where the rightmost byte gets shifted left, but we procrastinate actually writing it. We just keep it in the B, we hoard it until the very end when we figure out if we need to OR in the least significant bit of that byte. And then finally we write it. Okay, things are rotating 1 pixel at a time, I think, but only this half is doing anything. Nothing's going on over here, and it looks like my rows might be off because I want to rotate these pixels here, and I don't want to rotate this part here. This is like the aperture that we're going to be shooting through. I'd say close. This is better than my usual first attempt. I'm taking this as a win. Okay, I found a problem, and I think many of you will be able to relate to this. If you look at the basic code I used to draw the boss, you'll see I did some weird things with the x coordinates. I always have this ×2 thing. And the reason is that the GIMP pixel coordinates do not line up with the Coco pixel coordinates. Well, they do on the y-axis, but not on the x-axis. The way GIMP does it is, if it sees a pixel, it counts as 1. That is normal. The Coco is not normal. If you're in P mode 4, the resolution is 256 by 192. And every time that x-coordinate increments by 1, you're moving over 1 pixel. In P mode 3, which is where I'm at, the resolution is 128 by 192. And every time you move over 1 pixel, you're actually moving over 2 coordinates. And the reason is the coordinate system you're using in P mode 3 is actually 256 by 192. So in my basic code, I'm taking the sane pixel coordinate and I'm multiplying by 2 to scale it up to how P mode 3 works on the Coco. It's a bit weird, but whatever. As long as you know what's going on, you can get used to it. The problem is my scratch pad where I was writing out the sizes of everything was wrong. I was counting how many columns wide the boss was, and I was using the GIMP sane coordinates rather than the Coco insane coordinates. And that basically meant I just wasn't rotating and copying enough bytes. Rather than stopping at -5, I gotta keep going. I gotta do the whole thing. So I just had to add a bunch more code to do more rotates and more copies. Well, something is happening across the line. Vertically, looks like I did fix what needs to be rotated, kind of. But now that's kind of shifting here, and then that's bouncing back and forth. Okay. Okay, I see what I did. Remember how I told you I had to double the number of bytes that I was rotating and copying? Well, I doubled the number of bytes I needed to rotate for that first part, and then the number of bytes I needed to rotate for that second bit. But I didn't actually double the number of bytes I needed to copy in the cases where it doesn't rotate. So in the cases where it doesn't rotate, because that counter hasn't gone down to 0 yet, because we're waiting, because each row has its own speed, I needed to add all of this to copy actually the rest of the row. Okay, now it's going to work great. You just watch and see. Hey, all right. That looks pretty clean. All right, so now we can start getting those rows to rotate at different rates. Try a few things out and see how it works. For our first try, these are going from the bottom to the top. So the bottom will be slower than the next one, which will be slower than the next one. So the one on the top will be the fastest. Yep. I was kind of hoping for something where, I don't know, the periods of all the rows kind of line up every now and then, so it would like kind of be all together. I mean, this is fine, but it's not quite as cool. I want to try some cool things. I'm changing the numbers up a bit so that maybe the least common multiple is a bit smaller than before. Yeah, I think the difference in speed is more noticeable. Things don't line up very quickly in this one either. So now I'm doubling up some numbers, so maybe things will line up a bit quicker. And I wanted to get things going a bit faster. It looked a bit slow before. And also now as we go from bottom to top, we'll start fast, go a little bit slower, and then go fast again. Ooh, I kind of like that. Looks kind of interesting. Am I seeing it line up? Yeah, I kind of am. Maybe? I don't know. So I went along with that idea, but I kind of slightly changed the numbers so that they would line up with the size of the shield, so maybe it would be more explicit seeing those periods line up. Yeah, I think you can kind of see things Lining up and then unlining up. Maybe? Yeah, it's good. I like it. I also moved the boss a bit to the left so that the car will have an easier time of lining up and shooting it. Next time, we gotta get those bullets shooting through the shield. As always, thank you for watching.